Good day, viewers all over the world. So we want to continue our topic on complex number. We want to continue with complex number. We have started complex number. We've talked about addition of complex number. We've talked about addition of complex number, subtraction of complex number. We have talked about addition and subtraction of complex number. Subtraction of complex number. Then we have talked about multiplication of complex number. So today we want to look at the division. So we want to look at the division of complex number. Division of complex number. We want to look at division. Division of complex number. Division of complex number. That's what we want to look at. But before we can discuss about division of complex number, there's need for us to revise what is called the conjugate. Conjugate. We want to talk about conjugate. Okay. If this is a complex number, A plus IB is a complex number. A is the real part, B is the imaginary part because of this I. The conjugate of this complex number is given as A minus IB. If you can recall on that sort, when you talk about conjugate sort, conjugate simply means if you are given addition, then you change it to subtraction. That's the meaning of conjugate. And we should also note that if you use a complex number to multiply its conjugates, we are going to get a real number as our answer. That is, if I use A plus IB to multiply A minus IB, we are going to get a real number as a final answer. For instance, if you expand this, we are going to have A squared minus IAB plus, if this we multiply the two, we have plus IAB minus B squared I squared. Okay, this can take care of this. Then we have A squared minus I squared is equal to minus 1. Minus times minus is plus B squared. So this is the final answer. So let's take note that if we use a conjugate sort to multiply, then if you use a complex number to multiply its conjugate, we are going to get a real number at the end of the day. So please, let's take notes. Let's take notes of that. So let's take notes. Let's take notes. So the knowledge of conjugates will be required under division of complex number. So conjugate complex number. Conjugate complex number. When this, if this is a complex number, its conjugate is given as A minus IB. Okay. So I want to introduce division of complex number. Division of complex number. Division of complex number. So if, let's say example, division of complex number, let me just use example to buttress the point. If the question says simplify 3 plus 5i all over 3 minus 5i. This is the question. You know, this is division. We have numerator and denominator. If you have to do this, then the knowledge of conjugate complex number will be required. That is, this is 3 plus 5i all over 3 minus 5i. How do we simplify this? We are going to multiply both the numerator and the denominator by the conjugate of this denominator. This denominator is given as 3 minus 5i. Its conjugate will be 3 plus 5i. So we are going to say this is same thing as 3 plus 5i all over 3 plus 5i. So if you are given any complex number, which is fractional, and you ask to simplify, we are going to multiply both the numerator and the denominator by the conjugate of this denominator. So if we do that, what are we going to get? We are going to use this to expand this. 3 times 3 will be 9. Okay. 3 times 5i will be plus 15i. 5i times 3, that will be plus 15i. Then 5 times 5 is 25. That's plus 25i squared. Okay. All over 3 times 3 here will be 9. 3 times 5i, that will be plus 15i. Here will be minus 15i. Then we are going to have minus 25i. This will take care of this. At the end of the day, I squared is equal to minus 1. Minus 1 times 25 will be minus 25. So we are going to have 9 plus 30i minus 25, because I squared is equal to minus 1. Then at the denominator we have 9. I squared. So here also we have I squared. I squared is equal to minus 1. Minus 1 times minus 25, that will be plus 25. Plus 25. So at the end of the day, we realize that the final answer will now be, the final answer here will now be 9 minus 25. That's minus 16 plus 30i all over 34. That's what we are going to get. So if you do that correctly, that's what we are going to get. That's what we are going to get. That's what we are going to get. So that's what we are going to get. I squared is minus 1. So 9 minus, that's what we are going to get. So let's take notes. That's what you are going to get. And of course, you can split this. If you like, you can split this. You can split it as, we can split this as, you can leave it like this, or we just split it. If you feel like you want to split it, you can split it. If you feel like you want to split it, you can split it as minus 16 over 34, then plus 30 all over 34i. You can split it like this. It's still the same thing. So either you want to leave it as minus 16 plus 30i all over 34, or you might decide to split it. It's still the same thing. So under division of complex number, we make use of conjugates. Conjugate complex number. And of course, I've introduced conjugate complex number. That's what we're going to get. So let's take another example. Let's take example 2. Example 2. We have to simplify. When we have to simplify, we want to simplify 2 plus 3i all over 2 plus 3i all over 3 plus 4i. That's what we are given. So what do we do here? Still the same thing. Since this question is in form of fraction, complex number is in form of fraction. That's division of complex number. We are going to, this is what we are going to do. We have plus 3i all over 3 plus 4i. We are going to multiply both the numerator and the denominator by the conjugate of this denominator. That is, this will be 3 minus 4i all over 3 minus 4i. That's what we are going to get. So if we expand this, 2 times 3 is 6, minus 2 times minus 4, minus 8i, 3i, that will be plus 9i, then plus times minus is minus, 4 times 3 is 12, minus 12i squared, all over 3 times 3 is 9. Of course, when you have conjugates, when you have a complex number and conjugate, just square the first, square the second one. That will give us the result. But we can just expand. Let's expand. This will be minus 12i, then here will be plus 12i, then plus times minus is minus, 4 times 4, that's 16. We have 16i squared. This we cancel this. At the numerator, we are going to have 6. 9i minus 8i, that's plus I, minus I squared is equal to minus 1. I squared is equal to minus 1. So minus 1 times minus 12, that's plus 12. All over I squared is equal to minus 1. 16 times minus 1. Minus 16 times minus 1, that's plus. So we have 9 plus 16. So at the end of the day, 12 plus this will be 18 plus I all over 25. That's what we are going to get. So the final answer will be 18 plus I all over 25. The final answer will be 18 plus I all over 25. So that will be the final answer. 18 plus I all over 25. And if you like, you can split this. You can leave your answer like that, or you decide to split it as 18 all over 25 plus 1 all over 25i. It's still the same thing. It's still the same thing. So if you like, you can split it, and if you like, you can try to leave it that way. So that is that about complex. That's that about division of complex number. That's that about division of complex number. So let me introduce Argand diagram. So let me introduce the Hagan diagram. Okay. Let me introduce the Hagan diagram. So the Hagan diagram. This diagram is equally important under complex number. It's equally important. Now in complex number, we have the real parts. We have the real parts and the imaginary parts. Okay. Let's say this is the imaginary parts of Z. Of course, Z is equal to X plus IY. That's for complex number. Okay. So this is the real part, the real of Z. That's what. So here will be X as this. Here will be Y. And if you have, let's say this is theta, we can trace it to this place. So Z will be equal to what? X plus IY. Z is equal to X plus IY simply means that X is the real part, YY is the imaginary part because of that notation I beside it. So this is what we're going to have. So under the Hagan diagram, if you can find the modulus and the argument of Z, that's what the Hagan diagram simply means. We can find the modulus and the argument of Z. Then what will be the modulus of Z? What will be the modulus of Z? That's what we are about to see. The modulus of this complex number Z, the modulus of Z is denoted as, let's say Z. The modulus of Z is denoted as when we apply Pythagoras theorem here. The modulus of this Z, the modulus of Z denoted as Z is given as Z squared. When we apply Pythagoras theorem, no, this is Y, this is Z. Z squared will equal to what? S squared plus Y squared. And of course, when we take the square root of everything, this will be square root of S squared plus Y squared. So the modulus of Z is given as what we have there. The modulus of if you are given a complex number and you have to find the modulus and the arguments, just say the modulus is the value of S squared plus value of S squared. Everything square root. That's the modulus of Z. Okay? That's the modulus of Z. Then the argument of Z. The argument of Z is denoted. The argument of Z denoted as the argument of Z denoted as Z is given as this angle theta. That's the argument of Z. Then if you say tan theta here will be opposite all over hypotenuse. That will be Y all over X. Okay. What will not be theta? Theta will be what? Arctan of Y all over X. If you can still recall on that trick, that's what we are going to get. That's what we are going to get. So tan theta will be Y all over X. So theta, which represents the argument of Z, is given as arctan of Y all over X. So the argument of Z, arc Z, is same thing as theta. So theta, which is the argument of Z, is given as arctan of Y all over X. That's what we are going to get. So please let's take note that the argument of Z is this, and the modulus of Z is what you have here. Under the Hagan diagram, you know Z is defined as what? X plus IY. So if the question, if you are given a complex number and you are asked to find the modulus, just take the square root of the X squared, the value of the real part squared, plus the imaginary squared. Then if of that complex, just find the arctan of the complex part divided by the real part, and that's what we are going to get. So we just take one example under this Hagan diagram, then we close for today. Let's take just one example under this Hagan diagram. Let's take one example. So we might call that example 3. So in this example now, we have to find the modulus. We have to find the modulus and argument we are asked to find the modulus and argument of the complex number. And the complex number is 4 plus 3i. Solution. So we have to find the modulus and the argument of this complex number. So how do we find the modulus and the argument of this complex number? Of course, the complex number z is given as what? 4 plus 3i. So in this case now, x, which is the real part, is 4. Y, which is the imaginary part, is 3. So the modulus by formula is given as square root of x squared plus y squared. So this will be square root of x squared is 4 squared plus 3 squared. Then we have square root of 16 plus 9, which is square root of 25. Okay, so the modulus will be equal to what? 5, because the square root of 25 is 5. So if you have to find the modulus, just go ahead and find the square root of the real part squared plus the imaginary part squared. And that's what we are going to get. Then the argument theta, or we say as z, is given as arctan of the imaginary part all over the real part. Then this is going to give us arctan of y. Y is 3. Y is 3 and x is 4. 3 all over 4. So that will be arctan. Arctan of is 0.75. Of course, you can check this from a 4-figure table or just use your scientific calculator. So the argument at the end of the day will be approximately 36 degrees. That's what the argument will give us. So if you have to find the modulus and the argument of a complex number, is very simple. The modulus of a complex number by formula is given as this. Just take the square of the real part plus the square of the complex part. You now take the square root of everything. That gives the argument and the modulus. Then the argument will just be arctan the complex parts divided by the real part. You can use the scientific calculator to get the final answer, or use a 4-figure table to get the final answer. So I'd love to stop here because of our time. We continue from there in our next class. Thank you.